In this video we will have a look at the basic plotting command in MATLAB, and that one is called plot. And we will go through different features that you can access in the plot command, and that will actually translate very easily into any other plot type that you might need in your own work. So let's see how things are done. Plot command is used to create two-dimensional plots. So we talk about those where you have two axes, which in math you would think x and y. And the way to call is basically that you give the name of the command, which is plot, and then in normal parentheses you tell what you would like to plot. So now if you just give one vector in here, then MATLAB understands these as whatever you give it in here, whatever the name, MATLAB considers this as the thing that should appear on the y-axis. So it means that if I have, for instance, some set of numbers, I'll make a vector, and then I say plot y, so MATLAB will plot those values which we had, so 3, 9, 6, 3 and so on, are on the y-axis. And on x-axis it kind of puts just the index of a specific value. So you see 3 was first, so on x-axis I see 1, and then the value 3. 9 was second, so here is 2, and there is our value 9, and so on. If you have your y values given, but the respective x values are not necessarily just indices of those y values, then you have to explicitly point it out to MATLAB that what is your x values. So now I'll take the example here which is in the slide. We have x varying from -5 to 10. And then y is given as a formula x squared minus 20. And notice the dot in here, since x is a vector, then, and we want to square just the individual elements of that vector, we do have to put that dot before the exponential, so that we know MATLAB is actually taking one element at a time, making the square, and then the result will be a vector of squared elements. So once again, what I said, if you just say plot y, MATLAB will create the values that we have, but on the x-axis, it will put just kind of indices. So the first value was there, it's probably about 5, second value was something, so second here, third, fourth, and so on. But we know that our range of values should actually be from -5 to 10. So we have to point it here that MATLAB should actually put those actual values on our plot. Now as I keep plotting things, my figure now has, actually I have multiple figures. So there was one, there was another one, so you see I have multiple figure windows. And what is happening now? So if I put this command figure in here, that actually tells MATLAB that whatever I'm trying to plot right after it should be done in a new figure window. So it will always open up a fresh one for me if I have this figure. If I don't have it, it will overwrite the last available figure. So for instance, if I didn't have this, and I would like to modify somehow my plot, then this very last figure, which was the third one, here you see it says figure 3, would now be replaced. So if I have 2 times y, this whole thing should change values. It would be going down to -40 and so on. Let's see. And it will do it in that figure 3 window. So you see, it has changed. Now also, as you keep running code multiple times and you do create new figure windows and so on, of course you can close them manually if you wish, using the cross. But it is much more convenient to use in here the command close all. So now I know that when I run my new code, MATLAB will always close the previous figure windows. If for some reason I do want to see them, then I will comment this line so that I can see those previous. Maybe I would like to make a new run and compare the new one with the old. But a good habit is actually to have this close all and then consciously comment it when you really need to see the previous figures. Otherwise, when you run something multiple times, you may end up having dozens or hundreds of plots open at the same time. Okay, so now we know the difference between saying just plot y and plot xy. And so this is a basic, the very basic plot. And you can see that every time I have been plotting something, it kind of comes in a specific default form, and that is blue line. So that's the format, that's the default format for any plot. So unless you change that in the properties of the plot, you will always be getting a blue line if it's a single line. So now let's see how do we actually modify that. Well, after you give the information what you're trying to plot, there is the place to give the specifiers, or to change specific properties of the plot. So in a simple way, if you only want to modify the color of the line and its style, and you don't need to do, you choose one of the standard colors. So you can do it by simply telling the short letter for the color name, and then giving the line specifiers in here. So now let's look what are actually those line specifiers and then colors. So the solid line, the one we have seen, is by default given. But if you wish to know, you also can achieve it by typing a dash. So if I, in my code, in here, as a specifier, I give a dash, it will still keep the plot looking the same. And there it is. So it's still a blue line, just because a dash actually means that we want to see a line. If I want it to have a different color, or if first let's look at different line types. So if I want dashed lines, then I have to put 2 dashes, and then that's the result. Then we can have such an alternative as dash and dot. So that is done by putting dash dots in this order. And when you put that order the other way, so you first put a dot and then a dash, then MATLAB understands it a bit differently. It thinks that you still want a line, but you want to emphasize the actual points which are given here by the vectors. So what does it mean? Now we had those integers from -5 to 10 were integers, so with step 1. If I want to change those x values, for instance, like this, So now my y calculation will adjust, so it will have twice more values, and then of course the plot adjusts itself as well. But now you will see that those points are a bit more densely located, just because now they are every half. If before there was -5, -4, -3, and so on, now it's -4, -3.5, -3, -2.5, and so on. So remember the order. If you want still a solid line with emphasized points, then you put point dash, but if you want an actual dash dot line, then you have to change the order in here, as you can see. Then we can have just a dotted line, and for that use colon. And as I said, just a dash is still the solid line that we know. Okay, then when we know line specifiers, then we can look at colors. So blue is the default, which we have seen. However, there's a few other colors which you can kind of call just by giving shortly its name, or the letter representing it. And so we have R standing for red, G for green, B is for blue, C is cyan, M is magenta, Y is yellow, K is for black, since B is taken already, and W is white. Now this one you won't see unless you change the background of your plot to be other than white. But otherwise there are 8 standard colors that you can refer to just using one letter. So for instance, if I would like my dash dot line to be red, I just add R in here. And that's how it looks. You can check the other colors, cyan for instance. Alright, and then we can also have different markers for the points. So now in that example a while ago when I was showing you can actually have a line with emphasized points, if you just use a dot, they are actual small dots marking the points. Let me use a different color so that it's more visible. So they are those tiny dots added there. But you might wish to have something else instead of small dots. So you can actually use markers which are given here. So you can have plus signs, you can have circles. So this is small letter O, asterisk, point we had a look at, cross is letter X, small one, triangle is that hat, so the mark we use for exponentiation. Then diamond is letter D and square is letter S. So let's check a few of them. So for instance in here I say KS and the line. Now it emphasizes those points using a square. But if I want to see squares only, so I don't want to see a line connecting those points, I will just remove the dash. So now KS means black square for the point markers. And again, you can try yourself some other options. And then on top of all that, you can also decide on the size of those. So you can change, for instance, thickness of the line. Default is 0.5 point. If you want the line to be more prominent, then what you have to do is now after this basic information about our line specifier, we put a comma, and then we have to say what property we are changing, and I will be changing line width. So I actually have to type it like that in the small quotes because we're just giving a piece of text telling which property we are changing. So line width, and then the default is 0.5. I would like to see something thicker, so I'll put 2. So 4 times thicker line than what was there before. And there it is. You can also put something much thicker, for instance 10. then there it is. And similarly, you can change the size of the markers. So for instance, now if I wanted to have points with such a thick line, I will not see those points because they are somewhere there hidden under this very thick line. But okay, let's take some, maybe a bigger marker would fit, but not necessarily, because actually a standard marker size is 5. And now, if I remember correctly, it doesn't say here, but to my recollection, standard marker size is 5. So even if I use a bigger marker, like asterisk, we still will not see it. Only the first and last are somewhere there. But of course we can change the marker size, so I can make my asterisks much bigger. And once again, now after my line width change, I will change the marker size. So again, I name the property I'm changing, and then I give it a new value, and now I want something big, so let's make them 20. Remember that these are numerical values now. This is actual size in points. So it doesn't have this quote here. It's a common mistake. I do it sometimes myself. So if you see some kind of error, let's first draw this. So you see now those asterisks are big over our thick line. If I by accident put the quotes around it, let's see what kind of error we are facing. So MATLAB will tell us value not a numeric scalar. So then you have to kind of trace back what you've typed in here, and this kind of error normally means that one of the features that you should define in a numeric as a numeric value you actually gave as a text. Alright, and then you can also change marker edge color. So for instance, if there are those solid ones like triangle or circle, you can decide separately what's the edge color and what is the face color. So here are the two options. Alright, and so here's just another example. So there are some years and some sales of something, and then there's a small piece of code how that would be plotted. So it means we are giving our year data which goes to x-axis. Remember about the rules, which is x and which is y. So x is here, y is here, just like in primary school. And so we would have years on x-axis, y, so the sales on y-axis, and then this says that we want a dashed line in red color and with the sales points emphasized with asterisk. And our line should be thicker than usual, 2 points, and the markers should be of size of 12. And then there is another example where we just have some mathematical function. So for instance, if you have some very distinct points to plot, of course, this is how you go. You just define the two vectors like this. But for instance, if you have some math equation, some function you would like to see plotted, then what you have to do, you have to decide the x values yourself. And that's where normally, when you create the vector to represent your function, we use some relatively small step size so that the function is nice and smooth rather than with some very rough pieces of line connecting it. So let's take this one. So our y is 3.5. Power minus 0.5 times x. And that's still times cosine 6 times x. And now x in here was between -2 and 4. And with some small step. So before I run it, now let's again remember the rules of operating on vectors and matrices. X is a vector. So now it means that 6 times a vector, that's obvious for MATLAB. There is no problem with that. Cosine of that also is not a problem, because MATLAB knows that if a cosine function is given a range of values, be it a vector or a matrix, then MATLAB will simply calculate cosine of all those values. So there is not a problem, and the result of this will be a vector. But now 3.5 power a vector. So now this wouldn't be possible as such in algebraic way. But what we don't want to do any algebraic raising to power, which is a vector. What we want to do is that 3.5 will be raised to different powers, which are exactly the values appearing in our vector. So 1 by 1, and if it's 1 by 1, it means we do need a dot in here. So then the result of this will be exactly a series. It will be a vector which has as many elements as our original x. And now, since this is a vector and this cosine is a vector, so to get them multiplied, since they are oriented in the same way, they are both rows, we do need also the dot, so that we know that we are just multiplying them pairwise. So now we have our function, and let's do the plotting. X and y. So this one, you see the plot is nice and smooth. And if I had my step size much smaller, let's say 0.5, you would see that it starts to be very rough. So it only really calculates those individual points there and then connects them with a line. So this is the main feature of plot function you should remember. The basic thing is it basically connects given points with a straight line. So the more densely your points are located, now if I put it to 0.01, it should be already relatively nicer looking, yes, especially here where it's more flat, but the beginning is still pretty rough. So normally 0.01 is kind of a good number to go with. All right, so now what could go wrong when we are plotting? Of course, something can always go wrong, and errors are something we can learn from. So now if we have 2 vectors, and now I'm trying to plot, and here deliberately I'm trying to plot on x-axis my y-r vector, but on the y-axis I'm trying to plot this vector, all of it except the last element. And then I'll get error saying that vectors must be same length. So the basic message for you is that you try to plot 2 vectors which are not the same. The plot command requires that the x and y have the same amount of points. That's a must. So that's why here there was that mismatch. And then in this example, I have some mathematical function which I would like to plot, and I give the range of x values for calculating it, and then I try to plot it, and now I get error that matrix must be square. So the problem is in here in the formula that I have forgotten my dots. So actually it's not the plotting actually that is failing, but already the calculation of y. So in here I should have added a dot in this place and another one at least here. All right, then we go further. So if we go back to our sales example, we have again the years, the sales, and then we try to plot those. And I want dashed lines and a triangle, but I have forgotten that the marker for triangle has a different name. It's actually the hat, and I'm trying to use T as the marker name. So MATLAB tells me error in color line type argument. So this error is a message for you that the problem is somewhere here with the way you specify the properties of your plot. So that if you don't remember what specifier is there for triangle, you can go to help, for instance. You go to your plot, and that one should have the list of our properties plots. And as we scroll down, this one has also a lot of examples. You can go through them yourself. And somewhere we should find a list of, yes. So here are those tables I showed in the slides. There's a table for line styles, table for markers. There's actually even more than those that I have given. So now I look here for a triangle, upward pointing triangle, and there it is. And there's actually an option for downward pointing triangle. So you can decide it, and then there's right and left. So from here, you know how to correct your code. And in here, so we are again trying to plot the same stuff. We have the specifiers and so on, and then we're trying to change line width and marker size. And I have now deliberately forgotten to put the line width information, and now MATLAB is a little bit confused, seems like. Let's try to verify. This was from the old MATLAB version. Let's see how it would actually react in here. So I'll comment those, uncomment, and then remove that. Let's see. Oh yeah, so now it's much more informative. So there is no K-star line property on the line class. So it's basically somehow confused what is happening. Then you really have to trace back to what you've typed in here when it comes to your properties, basically. It may not come obviously from the error which exactly has the problem. All right, so with those things we went through, you have now the basic set of tools to make the simplest graphs. And that's when you are creating one line within a specific figure. And the further videos will show you how things are done when you want to have multiple lines within, or multiple pieces of information within one figure.